We are asked here to determine the equation of a line that is parallel to line L and that also contains the point 2, -1. So thinking about what this kind of looks like graphically, first of all, we definitely want this to contain the point 2, -1, but then also run parallel to line L. And so since we know that lines that are parallel are always going to have the same slantedness, or in other words, the same slope, we'd want this line to have the same slope as L. So it'd be important to know the slope of L, and so it does seem that there is a rise of 3 for every 1 unit of run, so it seems that the slope of L would be 3, which means that the line that we want to write an equation for that passes through 2, -1 needs to also have a slope of 3 to be parallel to L. So our line's going to, kind of look like this, and we want to determine exactly what the equation of that line would be. So knowing the slope of the line and knowing a point on the line should instantly tell you we can write this in point slope form. So you should be able to take y minus the y and equals the m times the quantity of x minus the x to get that into point slope form. And then we can solve this for y to get this into slope-intercept form. So I'm going to change the subtracting the negative there to a plus. So upon distribution, we have the following, and then by subtracting 1 on both sides to isolate y, then we end up with the following result, which seems pretty logical because if you did follow that line downwards a little bit more, it would cross through -7 there on the y-axis. And then here we are asked to write an equation of a line that passes through -6, 5 and is parallel to the graph of y equals -2/3 x minus 9. So we do know a point we want this to cross through. We want it to cross through -6, 5, and then also go parallel, which would mean go in the same direction as the graph of that. And so that would mean that we would want to have the same slope as what that is. And since that equation is in slope-intercept form, then we would know that the slope of this is going to be -2/3, since it's the coefficient of x. And because we want to be parallel, we'd also want the line going through this point to have that same slope of -2/3. So we do know a point that would be on the line we want to write an equation for, as well as its slope of -2/3. So here again, we can write this in point slope form and say that y minus the y coordinates is going to be equal to the slope times the quantity of x minus the x coordinates, using that known point and slope. And then from there, it's not asking for slope-intercept form per se, but if we do solve that, we would get -2/3 x, that's a plus, so -4, and then if I add 5 to both sides, we'll end up with y equals -2/3 x, and then plus 1, if we get that into slope-intercept form there. And then here now, we are asked for what is an equation of a line that is perpendicular to the line y equals 5/2 x minus 6, and that also goes through the point 0, -4. So we want it to go through this right here, which is 0, -4. It's actually the y-intercept, which is interesting. But we want to be perpendicular now. And what we know about perpendicular lines is that the slopes are opposite reciprocals, or their product of the slopes is always -1. And so if we want it to be perpendicular to this line, then since the slope of that line is 5/2, then a line that is perpendicular to that line should have the opposite reciprocal slope, which is -2/5. So we'd want to utilize that slope, and then also because we know a point in the line, we could write this in point slope form. So we could say that y minus the y is going to be equal to m, and then parentheses x minus the x, and then just do some solving. And so right there, you're going to get -2/5 x, and then of course -2/5 times 0 is going to be 0, so that's nothing over there, and then you just have y plus 4, so if you subtract 4, then you just get y equals -2/5 x minus 4, and that makes a lot of sense that we got what we got, because especially with the -4 right there, that's going to be the y-intercept, because this is in slope-intercept form, and of course, the point we were actually given was the y-intercept in this particular scenario. And then here we're asked to write an equation of a line that goes, again, perpendicular to the equation 6x plus y equals 4, and that also passes through P. So we can see P is plotted on the graph right there, which has coordinates 2, 5. So to be perpendicular to something means that we want to have an opposite reciprocal slope as that equation. Now, That equation, though, is not in slope-intercept form, so the slope there is not actually 6. So if we actually solve that equation for y, the equation solved for y is actually negative 6x plus 4, so that means the slope of this line is actually negative 6. So if we're going to go perpendicular, we want to be the opposite reciprocal of negative 6, and so the opposite reciprocal of negative 6 is going to be positive 1 over 6, and that's what we want the slope of the line to be for the equation that we want to write. And so then taking the point we want to have on the line along with the slope of the line, then we can write y minus y equals m times the quantity of x minus x, and then that would give you the equation of the line. And then just solving this, we would have y minus 5 equals 1/6 x, and then that would be negative 2/6, which really reduces down to negative 1/3. And then if you add 5 to both sides, I'm going to change 5 into thirds, which is 15 thirds. So then when we add those together right there, that's going to turn out to be 14 thirds. So we get a equation there in slope-intercept form, which would be like this in its finalized form.